So let's use dice as an example. All the possible outcome of 2d6. Okay, so this is some short form. This actually something come from D&D, Dungeon and Dragon. Okay, it means I toss a 6-sided die twice. So these are all the possible outcome. Now, instead of drawing these pictures, now I'm going to give you a very interesting polynomial. That is x1, x2, x3, x4, x5, x6 plus. Now let's say we consider x1 plus x2 up to x6 multiply itself. Then what we have? We will have this guy multiply x1, right? That is this. And then this guy multiply x2. That is this one.
And then this guy multiply x3. That is this one. This guy multiply x4. That is this one. And so on, right?
Then I have this column. So basically, what is the first column? The first column of this picture, the first output is x1. The second output is x1, x2, x3, all the thing here. Okay? Then what is this column? This column represents I have x3 multiply one by one each of them. What is this? This is the same as this. So if I use x1 to represent the outcome 1, then I get this picture. So for example, this one is 5, this one is 5, this one is 6, this one is 6, this one is 2, this one is 2, and this one is 5, this one is 5. I'm saying that they are the same thing, or there is a bijection. And with dice, what is their sum? So what is their sum? I add up their value. So in this, I'm also adding up the value. Adding up what value? Adding up the power. Okay, now high school thing. XA, XB is just XA plus B, right? X1 times X1 give me X2, X2 times X1 give me X3, X6 times X2 give me X8, X6, X6 give me X12. So from this arrow, I get this simplified table. What is this? What is this? This is X10. It is same as the value of 4 plus 6. Okay, so for example, what is this? This is same as 2 plus 2. Okay, so that means what? That means the three tables here are the same thing. So now, don't forget we are doing a bunch of plus here. Okay, so that means after the multiplication, we have all the plus sign. Okay, I just didn't write it down. Okay, and now suppose we do the summation of all the things. It will give me this polynomial. Now here's the funny thing. So this guy is 1x squared. So that means there's a 1x squared here. And then this guy, there's a 2x squared, which is there's a 1 here and there's a 1 here. And then now there's a 3x power 4 because you have a 1 here, you have a 1 here, you have a 1 here. And now I'm going to do this. So this is 4x power 5 correspond to this thing. 5x power 6 is 6x power 7. And lastly, this single guy go to here. So that means what? This is what? This is also the number of possible ways if you toss twice, and what is their sum? If I ask you toss a 6-sided die twice and asking you how many possible ways, the outcome, their sum is 5. So there are 4 ways you can get 5, which is 1 plus 4, 2 plus 3, 3 plus 2, and 4 plus 1, which correspond to this one, which correspond to they are the same thing. Okay? The same thing. So what I'm saying is that the table itself gives you the same pattern, not just if you consider the coefficient, it tells you something. And this becomes a very powerful technique to count the combinatorics about tossing die. Okay? And there's more. Okay? So now let's say we have a die that is defective. That is, output 1 is impossible. Let's say the die is defective, somebody is cheating. 1 is never possible. So if you look at the figure, I just hide all the 1. That means these are all the combinations that output contains 1. But now they are impossible. So I have this picture. Now let's say consider the polynomial. I put a 0 before x to the power 1. Okay? And now, previously, what is this two table? These two tables correspond to x1 up to x6 multiplied together. Now I have a 0 in x1, so ignore this x1. So I'm using a gray color here to make them look dimmer. And then what? This is the same table as before. This is the same table as before. But I just replace all the x1 with a gray color. Okay? And then after I do the sum of the power, I get this table. And again, all the terms with x1, I use gray color. So if I want to go to extreme, I can just cross it out because these are not going to happen. So I get this table. And don't forget, these are plus. So I will get a plus. And then give me this polynomial. What is this polynomial? Again, if I'm asking how many ways I toss this defective die twice and give me 8. So how many ways can I have? If I'm looking at this term, they says 5. What's 5? So which is? So what are the possible ways I have 8? Well, I can have 2, 6, 3, 5, 4, 4, 5, 3, 6, 2, right? How many of them? 5, 5, 5, 5, 5. You see, all of them are the same thing. So that means what? If I want to count the number of ways 2 dice give me 8. Instead of throwing it and then count a picture, how many of them give me 8? I can actually consider what? The coefficient x8 of this product. What is this product? This is product by. This die is impossible for 1, so I remove it, and I remove it, and then I find my x8, the coefficient, and it gives me 5, which is the correct one. That means what? I'm using bijection to do combinatorics. Look at this. How many ways can I distribute 8 cookies to 2 children with at least 1 cookie and no more than 6 cookies? So that means I have 2 children, let's say A and B, and at least 1, that means both of them larger than 1. No more than 6, that means smaller than 6, okay? So if I have this table, okay, what are these? This number add up give me 8. You may wonder, what about this one? This one said I give children 1 cookie, children 6 cookie. How many cookies are there? 7, which is not 8. I'm now saying I have to distribute all 8 cookies, so maybe it's better all 8 cookies, okay? But this is not important. The important thing is, if I want to distribute all 8 cookies among 2 children such that they have this relationship, I can just look at these red terms, which give me power 8. Okay, second example, how many ways can I distribute 7 cookies? Okay, let me make it clear. All 7 cookies to 2 children with at least 2 cookies and no more than 5 cookies. That means in this example, A larger than 2, smaller than 5, B larger than 2, smaller than 5. Okay, so first of all, I need to know there are 7 cookies. So that means I can only look at the diagonal with 7. Okay, so here are the diagonal with 7. But at least 2 cookies, no more than 5 cookies. So this one, no way, because 6 cookies is more than 5. 1 cookie is less than 2. And you know what? In the very beginning, I have already make this row, this column, this row dim. That means I have already made them gray, so that means meaning that they are impossible. Or in other words, I can just draw like this. Okay, this may be not good to the eyes, but my point is that means I only need to focus on this region, which is just the same thing here. And these are all 7 cookies, so I only need to consider this thing. And how many possible ways? 4, right? Because this is the 4 way you can distribute 7 cookies fulfilling this condition. So the answer will be 4. Okay, and what's the answer? The answer will be the coefficient of x4 of this guy. Okay. Suppose I have a plus b plus c equals 17, and now a has to be this, b has to be this, c has to be this, and a, b, c are integer. So how do you solve it? It's actually the coefficient x17 in the polynomial of this guy, which is 3.